For the prototype at least, I would recommend not dropping anything when you're near it. We are 70% water and only 30% land, and so really the availability of fresh water is simply about energy and trans. Elon Musk just walked on stage and unveiled a new engine, and within 48 hours, every major automaker on the planet was holding emergency engineering meetings, trying to figure out what they had just witnessed. The specs on the screen were not supposed to be physically possible. The manufacturing cost wasn't supposed to be achievable. What was unique about the Roadster? It was the first really great electric car. The performance numbers broke trade-offs the entire industry has accepted as gravity for the last 100 years. What Musk revealed that night does not just give Tesla a lead, it rewrites the rules of the EV industry forever. And once you understand what is spinning inside this motor, you will understand why the race is already over. The night the numbers leaked, the unveiling itself was almost anticlimactic. A stage, a presentation deck. Elon Musk, speaking in his usual halting cadence, pausing between sentences, occasionally glancing at his notes. From the audience, it looked like another Tesla product reveal. Then the spec sheet went up on the screen and the temperature in the room shifted. The motor on the screen was not what anyone expected, 20,000 revolutions per minute. Carbon fiber, wrapped rotor, a complete drive unit, motor power, electronics, and gearbox combined with a target manufacturing cost of approximately $1,000. Industry analysts in the audience had to read the slide multiple times before they believed it. Phones came out under the seats. Messages started flying between analysts and competing automakers within minutes of the spec sheet going up. We do expect, actually, to start fully autonomous unsupervised FSD in Texas and California next year. By the time the presentation ended, the murmuring in the back rows had stopped. People were already on their phones, already drafting notes, already calling sources at competing companies. And a question was beginning to form in the minds of everyone who understood what they had just seen. How is anyone supposed to compete with the physics wall? You have to understand the wall they just walked through. Electric motors are conceptually simple. Pass electricity through copper windings, create a magnetic field spin. A rotor generate motion. Any first-year engineering student can sketch one out on a napkin. But turning those simple principles into a motor that can power a high-performance vehicle while staying efficient, reliable, and affordable is brutally difficult. The problem is physics itself. When you spin a rotor at high speeds, centrifugal force tries to tear it apart. The faster you spin, the greater the force. Engineers have lived with this trade-off for a century. You can build a motor that spins fast and generates massive power, but it will be heavy, require extensive reinforcement, and lose efficiency to internal stresses. Or you can build a motor that is efficient and lightweight, but it will not produce the kind of performance that makes electric vehicles exciting. For years, every electric vehicle manufacturer simply accepted this. Performance cars sacrificed efficiency. Efficient cars sacrificed performance. The physics seemed insurmountable. And then Tesla did something that should not have worked. What if it wasn't the 3 words carbon fiber wrapped rotor? 3 words. That's the whole secret on paper. But behind those 3 words sit years of engineering refinement that took a problem the entire industry treated like gravity and made it routine. By wrapping the rotor in carbon fiber, Tesla's engineers created a structure that could withstand centrifugal forces that would shred a conventional motor. The carbon fiber acts like a compression sleeve holding the rotor components together even at rotational speeds that were previously impossible to achieve in any consumer vehicle. And here's what that unlocks. The motor can spin at over 20,000 revolutions per minute. Let that number sit for a moment. Most high-performance electric motors top out around 15,000 to 18,000 revolutions per minute. Conventional automotive motors operate at far lower speeds. Tesla's motor operates in a regime that was previously reserved for specialized industrial applications, jet engine accessories, military hardware, not consumer vehicles you can buy and park in your garage. Before we go further, do me a favor. If you've made it this far, hit the subscribe button now. the next part of this story. The part about what happens when you take this kind of motor and try to manufacture millions of them is where the carbon fiber stops being an engineering footnote and starts becoming an industry-ending weapon. You won't want to miss what comes next because raw speed means nothing without the ability to convert that rotation into usable power. And this is where Tesla's engineering becomes genuinely uncomfortable for the rest of the industry. The carbon fiber wrapping does not just allow higher RPM. It keeps the rotor perfectly stable at those speeds, eliminating the vibrations and inefficiencies that destroy conventional high-speed motors. A stable rotor means cleaner magnetic field interactions. Cleaner interactions mean more electrical energy gets converted into mechanical motion rather than being lost as heat or vibration. In conventional motors, that lost energy adds up to significant inefficiency, which is why most high-performance electric motors require massive thermal management systems just to keep operating at sustained loads. But the final step in the master plan, which is a mass-market affordable car, Tesla's design sidesteps that entire category of problems. Less heat generated means less heat to dissipate. Less vibration means less wear on bearings mounts and surrounding structures. Less internal stress means longer service life. Every metric that matters for a production vehicle improves simultaneously, which is precisely the kind of compound advantage that should not exist within a single design. The result is a motor that produces staggering torque from a standstill while maintaining efficiency at highway speeds. It is compact enough to fit in spaces that would be impossible for a conventional motor of similar power. It is light enough that it does not compromise vehicle dynamics, and it runs cool enough that it does not require massive cooling systems that add weight, complexity, and cost to the surrounding vehicle architecture. But here's the thing. Nobody outside the room understood at first. The motor was only the beginning of what Tesla had just shown. The Plaid shock, the Model S. Plaid was the first vehicle to showcase this technology in the wild, and the numbers it posted shocked the automotive world into silence. 0 to 60 miles per hour in under 2 seconds. Not approximately 2 seconds, not roughly 2 seconds. Under 2 seconds, a threshold that was previously the exclusive domain of million-dollar hypercars with the internal. combustion engines specifically engineered for straight-line acceleration, cars with stripped interiors, cars built to do exactly one thing, cars that cost more than most homes and required specialized maintenance just to remain operational. But the Plaid is not a stripped-down drag racer. It is a full-size luxury sedan with a complete interior, advanced technology features, and a range that makes it practical for daily driving. It can accelerate like a purpose-built race car, then drive 400 miles on a single charge. Then, with respect to supercharging, all Model 3S will come with supercharging standard. Then do it all again after a brief charging stop. It is in every measurable sense a car that should not exist according to the rules the rest of the industry has been operating under. This combination was supposed to be impossible. Industry engineers had run the math for years. The trade-offs that govern electric motor design said that you could not have brutal acceleration and long range in the same vehicle without massive compromises somewhere. You picked one side, you accepted the cost of the other. That was the rule. That was the math. Tesla walked into a presentation hall, put a slide on the screen, and casually informed the world the rule no longer applied. The compromise no longer existed. They had simply broken the equation everyone else was still trying to solve inside. Across competing automakers' engineering teams spent days trying to find what Tesla was hiding. There had to be a compromise somewhere, a thermal limit they were not disclosing, a durability issue, a cost they were eating. But the deeper outside teams looked, the worse the picture got. Every assumption their own electric vehicle programs had been built on was wrong. Every cost target, every performance benchmark, every timeline, not slightly wrong by a factor of 3 or 4. Wrong in ways that would require entire programs to be redesigned from scratch. The industry was no longer behind Tesla. The industry was operating in a completely different conversation. So how does this conversation end? It depends on something that is not the motor at all. The $1,000 unit. Building a high-performance electric motor is hard. Building millions of them at consistent quality while keeping costs low enough for mass-market vehicles is nearly impossible. This is where most electric vehicle startups fail. They can create impressive prototypes. They can dazzle investors with specifications. They can generate excitement with concept vehicles. Then they try to scale production and everything falls apart. Tesla spent years building manufacturing capabilities that are arguably more valuable than the motor technology itself. And during recent investor presentations, they revealed something that made competitors physically uncomfortable. Their next-generation drive units are being designed from the ground up for manufacturability, not just performance, not just efficiency. Manufacturability. The goal is a complete drive unit, motor, power electronics, and gearbox combined that costs approximately $1,000 to produce. $1,000 for a system that can propel a vehicle from 0 to 60 in seconds while delivering range and efficiency that leads the industry. To put this in perspective, current industry estimates suggest that comparable drive units from other manufacturers cost 3 to 5 times as much. Some cost even more. And then in terms of price, well, of course, it'll be $35,000. The gap is not a small advantage. It is a chasm. And every production innovation Tesla implements widens it further. This is the part that makes competitor finance teams genuinely uncomfortable. It is not just that Tesla can build the motor. It is that Tesla can build it for a price that makes building any competing motor at a profit nearly impossible. When your manufacturing cost is 1/3 of the competition's, you can charge less profit, invest more in the next generation, and still leave the competition struggling to break even on the current one. The next generation motors are also being designed to eliminate rare earth elements entirely. These materials, primarily sourced from China, have been a strategic vulnerability for the entire electric vehicle industry. Expensive, fragile supply chains, significant environmental costs, every automaker has been working to reduce rare earth dependence. Tesla appears to be on the verge of eliminating it completely. They are also dramatically reducing the silicon carbide required in their power electronics. Silicon carbide enables more efficient power conversion, but it is expensive and difficult to manufacture at scale. By redesigning their systems to use less of it, Tesla is cutting costs while keeping the efficiency advantages that silicon carbide provides. And the question every executive in Detroit is now asking is the same one engineers across the industry are asking inside their own teardown reviews. Where is the catch? The bleeding rivals? There may not be one, and that is what makes the rest of the industry's position so painful to look at. Consider Ford. They announced ambitious electrification plans with great fanfare, promising to challenge Tesla directly with vehicles like the Mustang Mach-E and the F-150 Lightning. The vehicles themselves are competent. In some ways, they're impressive. But Ford is losing money on every electric vehicle it sells. Not breaking even, losing money. Billions of dollars in losses subsidized by profits from their internal combustion vehicle business. Industry analysts have started describing Ford's electric vehicle program as a holding action, an attempt to stay relevant while hoping that costs eventually come down enough to reach profitability. Every year, Ford loses money on electric vehicles. As another year, Tesla extends its manufacturing advantages. By the time Ford figures out how to make money on these cars, the cars they are building may no longer matter. General Motors faces the same trap. They have invested heavily in their Ultium battery platform. They have introduced vehicles that receive positive reviews, but profitability remains elusive. Their electric vehicle production volumes are a fraction of Tesla's. Their manufacturing costs are higher. Their software, particularly after the embarrassing struggles with their Super Cruise system and various technology glitches, lags behind what Tesla offers. Toyota, the largest automaker in the world, has been even slower to adapt. They bet heavily on hydrogen fuel cells and hybrid technology, dismissing battery electric vehicles as impractical for mainstream adoption. That bet is looking increasingly catastrophic. Toyota is now scrambling to develop competitive electric vehicles, years behind where they need to be. Their first serious attempts have been underwhelming, plagued by recalls, limited range, and uninspiring performance. Volkswagen, which announced with great fanfare that it would become the world's leading electric vehicle manufacturer, has struggled with software problems, production delays, and quality issues. Their ID series has found buyers in Europe, but has not made significant inroads in the crucial American and Chinese markets. The company recently announced significant software problems and layoffs, and cost-cutting measures a sign that their electric vehicle transition is proving far more difficult than anticipated. The startups are not faring any better. Lucid Motors produces what many consider the most technologically impressive electric vehicle currently available, with range and efficiency figures that match or exceed Tesla's best. But Lucid is burning through cash at an alarming rate while producing vehicles in very small volumes. Their cars cost over $70,000 at a minimum, which limits their addressable market. They have repeatedly missed production targets. Their path to profitability remains unclear. Rivian generated tremendous excitement with its electric truck and SUV, attracting massive investments from Amazon and others. But the company is losing money at an even more alarming rate than Lucid. Production costs are far higher than projected. Every vehicle they deliver represents a significant financial loss. Without continued access to capital markets, their survival is not guaranteed. The only competitor that seems to pose a genuine threat is BYD, the Chinese manufacturer that has grown to challenge Tesla's position as the world's largest electric vehicle producer. BYD has mastered high-volume, low-cost manufacturing in a way that no other Tesla competitor has matched. They are expanding globally, entering markets in Europe, Southeast Asia, and Latin America. But BYD's success has come primarily in the budget and mid-range segments. They compete on price, not on cutting-edge technology. Their vehicles are adequate, but they do not push boundaries. They are not winning hearts. They are winning wallets, and even that advantage may be limited. BYD depends heavily on the Chinese market, where government support provides significant advantages. As they expand internationally, they face tariffs, regulatory scrutiny, and established competitors who understand local markets. Tesla occupies a different position entirely. Premium end of the market, higher margins, stronger brand loyalty, healthy profits while still offering value that customers perceive as superior to alternatives. They're not trying to be the cheapest option on the lot. They are trying to be the option that makes every other option look obsolete the moment a buyer test drives one. But the motor is still only one piece. There are advantages Tesla has built that have nothing to do with cars at all. And that is where the picture gets genuinely strange. Beyond the cars, start with the data. Every Tesla on the road is collecting information about how humans drive. Every mile generates data that feeds back into Tesla's systems, improving their understanding of driving patterns, road conditions, edge cases, and the countless variations that make autonomous driving so difficult. Tesla has accumulated more real-world driving data than every other autonomous vehicle program combined, not slightly more, overwhelmingly more. This data advantage compounds. More data enables better algorithms. Better algorithms enable more capable vehicles. More capable vehicles attract more customers. More customers generate more data. The cycle reinforces itself continuously. At industry conferences, executives from competing autonomous vehicle programs have stopped pretending they can close the data gap with Tesla. The math no longer works. Reaching Tesla's current data position would require millions of vehicles, years of collection, and a fleet that simply does not exist. Several major programs have quietly redirected their strategy away from chasing Tesla and toward partnerships, licensing deals, or limited deployments in geographic niches where Tesla does not yet operate. The shift is rarely announced publicly, but inside the industry, the surrender is no longer a secret. Then there is the battery situation. Tesla has invested billions in battery production, building their own manufacturing capabilities, rather than depending entirely on suppliers. Their partnership with Panasonic provided the foundation, but Tesla has been systematically reducing that dependence, developing their own cell designs and production processes. The battery cell, despite production challenges that have taken longer to resolve than initially hoped, represents a fundamental advance. Higher energy density, lower cost per kilowatt hour, improved thermal characteristics, simpler manufacturing. When fully scaled, 4,680 production will give Tesla a cost and performance advantage in the single most expensive component of any electric vehicle. Competitors are largely dependent on external battery suppliers, which means they are competing for limited production capacity, paying whatever prices the market demands, and accepting whatever technology their suppliers choose to develop. Tesla controls its own destiny. The vertical integration extends throughout the company. Tesla designs its own chips for vehicle computers and autonomy processing. When the global semiconductor shortage crippled other automakers, Tesla rewrote their software to work with available chips and kept production running. They designed their own seats, their own infotainment systems, their own power electronics. Every component they bring in-house is another area where they can optimize for their specific needs, rather than accepting compromises imposed by external suppliers, factories and dojo. And then there's the global manufacturing footprint. Fremont was the beginning of former General Motors and Toyota plant that Tesla transformed into one of the most productive automotive factories in North America. Shanghai followed a factory that went from bare ground to producing vehicles in under 2 years, a pace that legacy automakers said was impossible. Berlin came next, bringing Tesla manufacturing to Europe. Austin, Texas, houses what may become the largest factory in North America, producing both vehicles and batteries. Monterey is next, producing next-generation vehicles at costs even lower than current facilities can achieve. We do expect actually to start a fully autonomous, unsupervised FSD in Texas and California next year. This is not just expansion. This is global industrial infrastructure being built at a pace no competitor can match. And then there is the supercharger network. Tesla's charging stations are everywhere. They are reliable. They are fast. They are located in convenient places with amenities nearby. They work seamlessly with Tesla vehicles. No apps, no payment confusion, no compatibility issues. You pull in, plug in, and charge. Every other charging network struggles with reliability, accessibility, payment systems, or some combination of all three. The disparity has become so pronounced that Ford, General Motors, Rivian, Volvo, and others have announced they will adopt Tesla's charging standard, giving their customers access to the supercharger network. They are admitting publicly that they cannot compete with Tesla's charging infrastructure. Think about what this means. Tesla's competitors are now dependent on Tesla for a critical part of their customer experience. Tesla will profit every time a Ford or General Motors customer charges at a supercharger. Tesla controls the infrastructure that makes their competitors' vehicles usable. And then there is Dojo. Dojo is Tesla's custom supercomputer designed specifically to train artificial intelligence systems on the massive amounts of video data generated by Tesla's vehicle fleet. Most autonomous vehicle programs are limited by computational resources. They have more data than they can process, more experiments than they can run, more ideas than they can test. Computing power is the bottleneck. Tesla is removing that bottleneck with Dojo. Tesla can train new models faster, test more hypotheses, iterate more rapidly, and improve their systems more continuously than any competitor. They are not dependent on external suppliers for critical AI infrastructure. They're not competing for limited cloud computing resources. They are not waiting for NVIDIA to ship enough chips. They are building their own AI infrastructure tailored to their specific needs at a scale that dwarfs any other effort in the autonomous vehicle space. And the gap between Tesla's training capacity and everyone else's is widening with every quarter that passes. Because every additional Tesla on the road generates more data, and every additional unit of computing capacity processes the data faster than the competition can collect it. This is why Tesla increasingly does not feel like a car company at all. They're a vertically integrated industrial conglomerate with capabilities spanning manufacturing, energy, computing, and artificial intelligence. They happen to produce cars, but cars are almost becoming a secondary concern. The motor that started this story is just the visible tip of something much larger and much more difficult to compete with, which raises a question that nobody at the major automakers seems comfortable answering out loud. The question Detroit fears. The preliminary teardown reports circulating through European and American automaker headquarters all end on roughly the same line. Not a conclusion, a question. If the motor is this far ahead, what does it mean for everything else they are building? That question is now sitting on the desks of executives across Detroit, Stuttgart, Wolfsburg, Tokyo, and Seoul. And nobody, according to the analysts who track these companies most closely, has a confident answer. The internal memos that have leaked describe a kind of strategic paralysis. Catching up requires closing multiple gaps at once. Motors, batteries, manufacturing software, data, charging infrastructure, AI. Closing one gap is hard. Closing all of them while Tesla continues to advance is something nobody has yet figured out how to do. Better motors enable better vehicles. Better vehicles attract more customers. More customers generate more data. More data enables better autonomy. Better autonomy justifies higher prices. Higher prices create more profit. More profit funds more research. More research creates better motors. The cycle continues, accelerating with every revolution. Analysts increasingly describe the situation in terms that would have been considered hyperbolic just a few years ago. Industry observers are not asking whether Tesla's lead is sustainable. They are asking whether it is structural, whether it is the kind of advantage that competitors can ever realistically close. And the consensus, quietly in conference rooms and earnings calls and analyst notes, is shifting. Wall Street analysts have started revising their models in ways that would have been considered hyperbolic just a few years ago. For the first time in decades of covering the auto industry, the consensus is no longer modeling a competitive electric vehicle market. The consensus is modeling a single dominant player and the timeline by which everyone else either pivots, partners, or disappears entirely from the global automotive landscape. The short list of names expected to fall first is not a secret inside the industry. It is simply a list nobody wants to publish out loud just yet. Look, if you've made it all the way to this point in the video, it means you actually care about where this story is going. So do us a favor, hit subscribe right now because the follow-up video, the one breaking down what insiders are saying Tesla unveils next, is dropping soon and you do not want to miss it. Now here's what we want to know from you. Which legacy automaker do you think breaks first under the pressure? Ford, General Motors, Toyota, Volkswagen? Drop your prediction in the comments along with your timeline. We read everyone. And if you want to see the rumored project that even Tesla insiders are calling bigger than this motor, that video is on your screen right now. The race is over. Most of the global auto industry has simply not yet quite found the courage to admit that truth out loud.